Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my dear students. How are you? Hope that this lecture will also find you in best of your health. Uh, on a request, I am going backward instead of going forward today because I skipped examination practice question from chapter number 4. So I'm going to uh, attempt those questions today. Today I'll be discussing something about examination practice questions of chapter number 4. The first question is, Salma is a quality control inspector. She randomly selects 40 packets of the biscuits at the large factory. She opens each packet and counts the number of broken biscuits it contains. Her results are as follows. You know that now this is the data which has been collected by a quantity control inspector. So she have written it in this tabular form. This is a simple tabular form, and you know that when we select some data and count the data, that is the primary data. So maybe will be asked such type of question in yes, this is question number A. It is primary or secondary data to Salma. Now this is the primary data because she has counted it, and she has collected it by opening each packet of the biscuit. So it is the primary data, and she have written it in the tabular form. You see that this has been written in the tabular form. Is this data discrete or continuous? Give reasons why. Now this data is discrete because you know that it cannot be continuous data. It is either one biscuit is broken, or two biscuits are broken, or three biscuits are broken, or five biscuits are broken, or whole packet is broken. So therefore it is discrete data. We are only dealing with the number next to each other. That means 1 2 3 4 5. We are not dealing with 4.5, 4.2, 4.8, or 3.4 or 5.6. We are not dealing with these. So this is the discrete data. Now since it as I told you that it has taken the certain values like 1 0 2 4 6 8 and so forth. So question number part A is that it is primary data, and B, it is discrete. So it now these are the oral questions. Now copy and complete this frequency table to organize data. Now we have to copy this table. So it is very easy. Let me do it for you. It is very easy. I have already you know that using the this register, and maybe it will be. Now this is number of broken biscuits, and the next is tally, and the next is frequency. I'll draw some lines over here. The more you make it neat, the more it will be presentable. Now my dear student, as you see that I have reproduced the table in the first column. Now this, you know, this is the column and these are the rows. In the first column I have written number of broken biscuits as it was written in the given table. The tally mark, you know what are the tally marks, and frequency. Now I will be doing from 0 to 4. From 0 to 4. This is given 0, 1, 2, 3 and 4. Now these are the 5 quantities. Now number 1, these are given. Number 2, that either you get 0 broken biscuits, that means no broken biscuit, or 1 broken biscuit, or 2 broken biscuit, 3 broken biscuit, or maximum up to 4 broken biscuits. So we have to count all the um, data which is provided to us. Now this data will be secondary data. Now this is going to be in the form of the secondary data. The first table which was given to us was the primary data. So this is the primary data. You see that there is one zero, there is another zero. We'll count each of the zero from the table and we'll put a tally mark over here. Now you see that we are going to do it like this. Hope that you'll. Now for first zero, one tally mark. For second zero, second tally mark. For third zero, third tally mark. For fourth zero, fourth tally mark. Now you see that these two columns have been ended, and for the fifth zero, now this is the fifth zero in this table. This is the fifth zero in the table. So I am going to cross the four tally marks. Cross the four tally mark. Now this is the way how we make the tally marks. 1, 2, 3, 4, and this is the fifth. So this is the fifth tally mark. 0, 2, and again from 1, 2, 3, 4, 1, 2, 3, 4, and this is the fifth tally mark again. Now 0. So this is completed. Now what we have is 11 tallies. 5 plus 5, 10, and 1, 11. We have 11 biscuits which were came out as to be whole biscuits. Nothing was broken in that. So 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this was the 12th. So we have come up with 12 packets of the biscuit which have no breakage. So you see how we did it. We counted 1, 2, 3, 4 and crossed with the fifth one. 1, 2, 3, 4 and crossed with the fifth one, and 2 are separately counted. So this is 5 plus 5 plus 2, that is equal to 12. Now the frequency is 12. The frequency is 12. Okay, now with number 1. Now this is number 1, one first tally, and in the second column one more tally. There is nothing in third, in fourth, yes, 1. In fifth column there are two ones, 1, 1. So 1 will be the fourth and 1 will be the crossing the fifth, the four tallies. Now 1 again, 1 again, 1 again, and 1 again. Now these are total 9. 5, 6, 7, 8, and 9. So write 9 over here. Now 2. The first 2, second 2, third 2, and fourth 2, fifth 2. Okay. No twos, no twos. Yes, there is 1, 2 over here, 1, 2 over here, 1, 2 over here, and 1, 2 over here, and 1, 2 over here, and 1, 2 over here. So like this. You see that there are 5 and 5, 10, and 1, 11. 11 twos. Number 3. 3, 1 tally mark, 2 tally mark, 3 tally mark, 4 tally mark, 5 tally mark, and 6 tally mark. 5 and 6 and 4. Last is 4. No 4 is appearing. No 4 is appearing. No, 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 no. Yes, there is only one. Okay. Now what we will do, I'll just count these to be sure that I have counted the right frequencies. Now 9 plus 2 is equal to 11, 12, 12, 6, 18 and 1, 19. I have missed one. Let me check it again. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is okay. For number 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now these are in fact 10. Okay, now it is completed. Now uh, 6, 7, 8, 9, 10. 1, 2, 3, 4. Okay, now it is complete. I just missed uh, one tally mark over here. So this is complete, and the frequency we have come up to 40 now. So what is the next question? This was the third part of it. It was the third part of it. It was C. Now the fourth part. What type of graph should Salma draw to display this data? Why? Now she must display. There are many choices to her, but the best choice would be the bar graph. So bar graph is like this, and like this, and like this. Broken biscuits, and now these are the broken biscuits, and for here you can do the frequency out of it. Now how many are the broken biscuits? There were 4 broken biscuits, so maximum of 4 broken biscuits. So this is the 0, this is 1, 2, 3, 4. Now what is the frequency over here? The frequency was in the last page. This was 12, 1, 2, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from 0 to 1, these were 12. Now it can easily be drawn like this. From 1 to 2, there were 10. So it will become over here. 3, 11. Now this is 11. 6, 0, 12, 1 तो 2, 10, 2 तो 3, 11, 3 तो 4, सामने है, नहीं बना लगा, छोड़ो फिर। तोते ने बोलना शुरू कर देता है, हाँ हाँ जी। Number of books and frequency. Now, my dear students, about the last part. What was the last part? What type of graph should Salma draw to display this data? Now, she have many options, but the best option be the bar chart. So, how will we draw the bar chart? Let me display it to you. Though it has not been asked to you, but for your knowledge, I'm going to display it, draw it for you. You see that these are the two axes. Okay, now we'll take frequency over here and number of biscuits over here, number of broken biscuits. Now these are the number of broken biscuits. Broken biscuits. These are the number of broken biscuits. Now here we'll take 0. Here we'll take 1. Here we'll take 2. Here we'll take 3. Here we'll take 4. Now about the frequency, let me take it like this. 1, 5, 10, 15, 20, or 2, 4, 6, 8, 10, 12, and so forth. So these are the frequencies. So you see that this is 0 once again, 2, 4, 6, 8, 10, 12. So we'll take this thing. What is the value? What is the frequency of 0? This is 12 over here. You see, this is 12 over here. We have already solved it. This is 12. So what will we do? You see that this will be like this and like this. And then we'll color it. Now you see the 0 has risen up to 12. Now the number of one biscuits which were broken is 10. So we'll come up till here. Then I'll draw a bar and then we'll color it. Okay. Now this is the rough sketch, and similarly we'll be doing it like this. 10 and a little 11 over here. Now this is like this. Okay, now this we color it with some different color. 6. Next is 6. Okay, now I have completed your first question. It was very easy. And the fourth is only 1. So here will be 1. Color it. Now you see that how I made this bar diagram. Now this is the bar diagram. Now you see that from the bar diagram, our question number, part number 1 is also displaying that this is the discrete data, because you see that there is a gap in between each of the bars. There is a gap, there is a gap, there is a gap, there is a gap. So this is a discrete data. So the first question has been completed, and now I'll be doing question number 2 for you. Now question number 2. The number of aircraft movement in and out of 5 main London airport during April 2017 is summarized in the table. Airport: Gatwick, Heathrow, London City, Luton, Stansted. And total flights are these: 22,696, 39,660, 6,380, 10,697, and 15,397. Now, what are the questions about this table? What are the question about these tables? Now, question number one, or the part number one for question number two, is which airport handled most aircraft movement? It is very obvious. We'll see that these are 23,000 and this is 39,000, this is 6,000, this is 10,000, this is 15,000. So Heathrow Airport has handled most of the aircraft movement. So the answer for part A will be Heathrow. Answer for part A. Now question number two, part A is Heathrow, because Heathrow Airport has handled how much aircraft? It has handled 39,660 flights. How much aircraft moved in and out of Stansted Airport? Stansted Airport. Stansted, Stansted Airport was 15,397 flights. Now this is the answer. This is the answer for question part B, and this is the answer part A. Round each figure to the nearest thousand. So it is very easy to rounding off. Now for the first, it is 23,696. Now you see that we have to round it to the nearest thousand. We have to round it to the nearest thousand. Now it is very easy. Now the thousand mark is this one. This is the thousand mark. You see, this is the thousand mark: unit, 10, 100, and 1000. Now this is the thousand mark. We have to make it to the nearest thousand. Since the 100 is 600 now. There are 600s, because now up to 5 we would have considered it to the lower value. But when it crosses, if it was 23,499, we have left these. We would have left these. We would have written it like this: 23,000. Now this is the nearest thousand. But for this, because it has crossed 500, it has crossed 500 over here, so we'll write it as 24,000. What we will write? We will write it 24,000. Part and same Heathrow Airport. Now for Heathrow Airport, I already have the value is 69. Now this is again has crossed the 500 mark, so it will become 40,000 flights. 40,000. London City. London City, 380. Now do you see, these are 380 over here, below 500, so it will become 6,000. And 10,697, 10,697, it will become 11,000, because it has crossed 500 limit. 15,397. Again you see, below 500, so we will just skip these flights, so it will become 15,000. So these are the answers. These are all the answers we need. These are the rounded figures. These are all the rounded figures we need. For 23,696, 24,000, and similarly for the last, it was 15,397. Yes, and I have tell you the formula for doing for rounding off. Now what was is the uh, use the rounded figure to draw a pictogram to show this data. Now part D, use the rounded figures to draw a pictogram to show this data. Now these are the rounded figures. The okay, this was Gatwick. Second one was this is, for example, Heathrow, London City, Luton, and Stansted. Now this is the data which we needed in our next uh, part. Gatwick, we have to use the rounded figures. We have to use the rounded figures. Gatwick 24,000, Heathrow 40,000, London City 16, Luton 11,000, and Stansted 15,000. So I'll be using to make it a pictogram. Now we have to pictogram. I have to draw a pictogram out of it. I told you, my dear student, that what does pictogram mean? Picto has come from picture. So we'll draw a picture out of it. Some picture we will draw like this. We'll be drawing like this. We'll be drawing like this. We'll choose any picture, or we can even draw a picture of an aeroplane. Okay, now we have to select a picture out of it. Let me select aeroplane because it relates to aeroplanes now. It relates to aeroplane. Now what we do, we'll do like this. I'll draw some. Now our maximum number in our data is 40,000. Our maximum number is 40,000. What is our maximum number? It is 40,000. Let me select the key first. Now key is if there is only one aeroplane, it means 10,000 flights. One aeroplane will show you 10,000 flights. Okay, now it is very easy that to show 10,000 flights. Now here are the flights, airports. Here are the airports, and here are the flights. So airport is Gatwick, Heathrow, London City, Luton, and Stansted. Now for Gatwick, there are 24,000 flights. 24,000 flights. For 20,000s, we can draw two airplanes. Now this stands for 10,000 flights. Now again another. This stands for 20,000 flights. And for half plane it will be 5,000, and for less than half it will be, let me say that it will be 4,000. So only wings, I'll draw only wings. Okay, now this is 24,000. For Heathrow, these are 40,000. So it is very easy to draw 4 planes. 10,000, 20,000, 30, 40. So you see how the pictograms are being made over here. Now the London city. London city has 6,000. 6,000. So it is less than 10,000 and more than 5,000. So more than half plane will be covering 6,000. So this is London. Luton 11,000. More than, now this is the first 10,000, right? And only this one. Only this one. And Stansted, again a full plane for 10,000 and 5,000 for half the plane, half of the plane. Okay. Now you see that I have drawn a pictogram. Now you can draw it in this way. This can be drawn in this with the square also, with the circle also. I think in for the circle or for the square, it will be more easier to show these sort of fractional items. Now this is a fraction, this is a fraction, this is a fraction. So anyway, we will write key for one plane. It will be 10,000 flights. So it is drawn. It is 20,000. Question number 2. Now question number 3. This table shows percentage of people who own a laptop and mobile phone in 4 different districts in a large city. A, B, C, D. Own a laptop 45, 32, 61, 22. Own a mobile 80 through 20, 72, 85, 68. What kind of table is this? Now, what kind of table is this? And you know that it is giving you the two information. It is giving the information for two variables. Now it is for the people who own a laptop, it is for the people who own a mobile. So it is a two-way table. Two-way table because it is giving us two information in one table of two variables. Now what kind of table it is? It is a two-way table. It is a two-way table. Question number 3, part A. Question number 3, part A is a two-way table. If there are 6,000 people in district, how many of them own a mobile phone? Now, in fact, these are the percentages. These are the percentages. This table shown as for the laptop and mobile, percentage of the people who own a. So, question number B, part number B asks us if there are 6,000 people in a district, how many of them own a mobile phone? How many own a mobile phone? Now I have to select a district. Now district is not given. So for example, if I start from district A, which is given to us, is now this is, you see that this is district A. This is district A, and we have asked about the mobile phone. Now this is the district A, and we have asked about the mobile phone. Now in district A, there are 83% people who own a mobile phone. Now what I have to calculate is 83 of 63%. 83% of 6,000. 83% of 6,000. So it is very easy. In my percentage in the chapter of percentages, I am doing these sorts of questions. Now 83 means 83 divided by 83% means 100 of 6,000 is like this. Now you will see that this has been crossed with this, so we'll multiply 83 with 60 or 6 only. 6 3 times 6 3 times 18, 6 18 48 and 49. 0 for the 60. So for district A, if I choose 83%, the people who own the mobile phone will be 4,980. 4,980 for district A. Because the district is not given, so I have taken at my own choice. Okay, you can also do it for D as well. Now you see for D district has 68%. 68% of 60,000. 6,000. So it is same multiplied by 6,000. These two zeros will go with this. 68 by 6, 6 48 and 6 6 36 and 40. 6 8 times 48 and 6 6 times 36 and 40 40. Now in district D there are 4,080 people who own a mobile. If 68%, if 6,000 of the people are there. Okay, one district is a home to University of Technology and several computer software manufacturers. Which district do you think this is? Why? Now this is a question which shows that influence of any market. Influence of any market. Now this question shows the influence of the market. Now you see, if you have a market near you, you'll go each and every time to collect some commodity from here. So it has asked, one district is home to University of Technology and several computer software manufacturers. Now there is one district which is near to that market, and for my experience it is district C. Now you see that the maximum of the people that are 61% own mobile phone or laptop, and 85% own it a mobile phone of that district. So it means that they have facility to collect mobile phone or software or such electronic items. So the maximum, the influence of the district C is showing us that this C is quite near to that market. Draw a compound bar chart to display the data. Now I have to draw a compound bar chart. Now dear student, I have already done question number 3 and part A, B, C. Now question number 3, part D. Draw a compound bar chart to display this data. So this is very much easy. Again we'll take two axes. Appropriate scale like this and like this. Okay, now here are the percentages. Here are the percentages. and here are the devices, and here are the devices. Now devices consist of a laptop and a mobile. There are two devices. For black I'll be doing laptop, and for mobile I'll be doing red. So there are four districts. Percentage of four districts are, now let me take it from 20, 40, 60, 80, 100. So in district A, now here is A, B, C. You'll select a suitable scale over here, and D. There are four districts. Now in A, the laptops are 45%, somewhere here, and the mobiles are 83%, somewhere here. Okay, now let me draw it. Compound bar diagram. Now this is compound bar diagram. Now this completes our 40. It will be more visualized when you uh, draw it on the graph paper. Now this is 45%. This is 45%. Now this is, now I told you that the devices, in devices A for black we'll give it to, now this is the key. For black it is laptop, and for red I'll be going to do a mobile. Mobile. Now this is our whole story. For black it is laptop, for red it is mobile, and in district A 45% of the people are having laptop, and how much people are having mobiles are 83%. Here you see B 32% mobiles, laptops. District B 32% laptop. Now 32 will come somewhere here. This is 30, and little above that is 32%. Now let me draw first bar, top of the bar, and 72% are the other devices, and that are mobiles. Now 72%, 60, here it comes 70 and 72%, somewhere here. It is almost a rough sketch you will make neat when you will draw it on the graph paper. Okay, I hope you are following my point. For C is 61% and 85%. 61%. 61% will come over here, just above the line, and 85%. 80 is here, and 85 here, above the line, not touching the line, above the line. Now this is like this, and like this. This is the laptop, mobiles. Red are the mobiles, and black are the laptops, just above this line. And similarly the last, and last is 22,868. Now this is 20, and just above it is 22. It is 22 and 68. Now here it is 60, here it is 70, and just below 70. Now you see, my dear student, that we have completed a bar diagram. Now this is a compound bar diagram showing the percentage of the devices. These are the devices and these are the districts. So the table has been transformed into graphical representation, and this graphical representation tells us the compound diagram for two devices, that are laptops and that are mobiles. And the key is written here. We can easily judge which are the laptops, which are the mobiles, and by reading this you see that uh, in district A, for example, in district A there are 45% people who own laptops, and about 80 to 83 people, 83 people per 100, or you can say 83% people have mobile. And similarly you can easily do it like in this fashion, and it will be very much more easier if you draw it on the graph paper. So it is question number 3. Now question number 4. Question number 4. This table shows a sample of people in Hong Kong to travel to work.